Let's now talk about bases or alkalis. Bases and alkalis are actually metallic oxides or hydroxides, and we define them using the neutralization reaction. If you can recall from my video on acids, okay? So the neutralization reaction refers to acids plus bases or alkalis producing salt and water only. We actually define bases or alkalis on this chemical reaction, and chemically speaking, they will be metallic oxides or metallic hydroxides. Those metallic oxides which are insoluble in water are what we call bases, and those that are soluble in water, we call them alkalis. It's way easier for us to remember which ones are alkalis because technically we only deal with about 4 of them. We have sodium hydroxide, potassium hydroxide, calcium hydroxide, which is also known as lime water, our favorite reagent for the test of carbon dioxide gas. And then lastly, we have ammonium hydroxide. What can we say about them? Well, we do also have strong alkalis and weak alkalis. The way that we talk about them is exactly the same definition that goes for strong versus weak acids. The degree of dissociation. So what happens when sodium hydroxide, potassium hydroxide, and calcium hydroxide, when they dissolve in water, they are the strong alkalis, and the reason why they're strong is because once they dissolve in water, they will fully ionize and they'll give you ultimately reasonably high concentration of hydroxide ions in the solution. For ammonium hydroxide, it is our most recent up to this Sec 3 and 4 syllabus. It will be our prime example of a weak alkali. It will only do partial dissociation when dissolved in water. So ultimately, you will still have some hydroxide ions in the solution, but not that much. Any other things? For physical properties, we do have alkalis and bases. They do have the ability to taste really, really bitter. That's one of those things, but I definitely do not recommend that you dip your finger in and go taste it, no matter what anybody else says, especially not in the school lab, okay? Try not to do things like that because you never know where that solution has gone to and what kind of containers it's been in that's dangerous. So ultimately, the first property is that alkalis will taste bitter. The other one is the fact that alkalis will actually turn red litmus blue. The blue litmus should actually stay blue. Chemical properties wise, frankly, there are only 2. The first one I've said before is the neutralization reaction. The second one, this is really important. Triple asterisk this one if you can, people. So what happens over here is that this second one is the only reaction for the whole of Sec 3, probably, that will produce ammonia gas. So when you react an ammonium salt with either a base or an alkali, it will give you salt, ammonia gas, and water. Now, I'd like to elaborate a little bit about this reaction with either a base or an alkali. If you react an ammonium salt with an alkali, it's very simple. You're actually adding it to a solution and you can warm it up. Then immediately you see bubbles of gas coming out and you test the gas. It will change the red litmus blue. If you reacted it with a base, that means it's a metallic oxide which is insoluble in water. Sometimes the amount of heating that you have to do might be a little bit more before the gas bubbles can start to be produced. So that's where, practically speaking, you might have to be a little bit more patient when you're doing this in the science lab. Other than this, that should be the most significant parts of bases and alkalis. If you like what you hear and you would like to show me some support, please do click the like button and subscribe to my channel. See you again.